Hi guys, I'm going to give you this little video just in case you're not in school today to explain this lesson. This is using area models, and you might have done something like this in the earlier grades when you learned about multiplication. It's basically using place value to help you multiply. Okay, the concept of multiplication and the area of a rectangle are closely related. We can use this relationship to help us both understand how polynomials are multiplied and to give us a visual tool to accurately find products involving polynomials. Find the area of the rectangle using the standard algorithm for multiplication by hand. So basically, how did you do it when you were younger? We would do the ones columns times the one. Whoops, I didn't mean to put that there. So we would put the ones column times the ones column. That would be 2 times 3 is 6. And then the ones column times the tens columns, 2 times 2 is 4, but that's really a 40. And then you would either add a 0 or leave a space. And 1 times 3 is 3. And that 1 is really a 10. So that's really a 30. Okay. And then 1 times 2 is 2. And that's really 10 times 20. So it's really 200. When you add that together, you get 276, and it's feet times feet, which would be feet squared. And that's the old-fashioned algorithm, or some people used to call that column multiplication. Well, this idea that we're using is that we're going to take the 23 and break it down into 20 and 3, 20 plus 3, which is 23. And we're going to take the 12 and break it down into 10 plus 2, which is 12. So now I could do each little rectangle, and I would do 20 times 10, 10 times 3, 2 times 20, and 2 times 3. And so I found the area of each of the smaller pieces. And then if you add all the areas together, you would again get that 276, which we're saying is feet squared because the units are feet. And that's the basic idea between using the area model for polynomial multiplication. So now, instead of saying that I have this rectangle that's an actual number, I'm saying that I have this rectangle with a side length that is a binomial or a polynomial. And I'm going to use the same old-fashioned algorithm, which is called, column multiplication. So I'm going to do 2 times 3, constant times constant, and then 2 times 2x, which is 4x. So now I'm going to do the x times the 3, which is 3x. And it only makes sense that you would put the 3x and the 4x in the same column because those are like terms. And then x times 2x would be 2x squared. So now when I get my final answer, it's 2x squared plus 7x plus 6. And that would be just doing regular multiplication. Okay, so now how does the area model relate to that? Same exact idea. So I'm going to do 2x times x. So I'm going to say that this smaller rectangle has an area of 2x squared. And then this rectangle has an area of 3x, 3 times x. This rectangle has an area of 4x, 2 times 2x. And this smaller one here has an area of 6. And then you're going to combine like terms, and the like terms are going to be right here along the diagonal. So once again, I get the same thing, 2x squared plus 7x plus 6. And it's just looking at it in another way. So basically what you're doing is you're drawing this area model or this square or this box based upon how many terms you have. So I have a binomial times a binomial, 2 terms times 2 terms. So I'm going to have 2 across the length and 2 down the width. So I'm just going to put the 4x and the plus 7. And remember, it doesn't matter which one you chose to put where because that's the commutative property. And then I'm going to put the 3x and the plus 2. So now I'm going to find each of the smaller products. You could call those partial products if you want. So 4x times 3x is 12x squared. 7 times 3x is 21x. 4x times 2 is 8x. And 2 times 6 is, 2 times 7. I saw the 6. 2 times 7 is 14. Okay, so now when you put that back together, you're going to combine the like terms and they're along the diagonal. So that's going to give me 29x plus 14. And you can just check that quickly by saying 4x times 3x, 12x squared makes sense, 2 times 7, 14 makes sense. And then you can add those partial products together there to just make sure you get the 29. Okay, so it's sort of like breaking it down to put it back together. One of the things I like about this method is that it's very organized and it helps you find your like terms easily. So we're going to use the area model and find the partial products. Okay, so I have x and a plus 8. I have x and a plus 2. X times x is x squared. 8 times x is 8x. X times 2 is 2x. And 2 times 8 is 16. I'm going to combine the like terms along the diagonal, and that gives me x squared plus 10x plus 16. So when you find your partial products, you have to then combine the like terms to find your final answer. All right, so why don't you just pause this video and try the rest of them, and then unpause the video to check your work. Okay, it would be really a good idea for you to practice this by yourself instead of just copying what I'm doing. All right, so pause the video and then come back to check. Okay, so I'm going to split this, and it's a binomial times a binomial again. And that gives me 15x squared for the first partial product, 12x for the next partial product, negative 10x for the next partial product, and then negative 8. Always following the integer rules. Positive times positive is positive. Negative times negative is positive. And a positive times a negative is a negative. So now you're going to combine the like terms along the diagonal, and that's basically saying 12 minus 10, which is 2. Okay. All right, so I have 2x minus 7 and 8x minus 5. And if you ever need to just use your calculator to reconfirm any of your products, there's nothing wrong with that. Feel free to use your calculator at any time. 2 times 8 is 16. 8 times 7 is 56. 2 times 5 is 10. 7 times 5 is 35. And that's a negative times a negative is a positive. So I have 16x squared minus 66x. Same signs, find the sum, plus 35. Okay. Now you can also use your graphing calculator to check these because, the binomial times binomial is like the question. Those are the two factors that when you multiply them, you get the product or the answer, which in this case has been a trinomial every time. So one of the ways that you can check this would be to take your graphing calculator and in your y sub 1, put the question, the factors. So I have the factors of 2x subtract 7 and the other factor of 8x subtract 5. Now, this isn't going to give you the answer, but it is going to tell you if they are equivalent. So I have 16x squared minus 66x plus 35. And this is what I do believe for the product to be. So, I can hit the graph and, these are pretty large numbers, so you may or may not see a picture. Oh, I did. So, what would happen is you would see the picture in one color, and then if they're equal, you would see the picture go over it. So the two graphs are equal. You could also look at the table, and you'll see that they have equivalent values in the table, which means they're equal expressions or equal polynomials. Okay? So that's one way that you can check it, which is pretty cool. So the graph, you'll see one right next to the other. And I'm just going to quickly show you what happens if I make a mistake. So let's just say that I made a mistake and I didn't know that negative times negative was a positive. So now when I hit graph, you'll see they don't overlap each other. They're not equivalent, okay? So it's a great way to double check yourself. No, it doesn't do the work for you, but it will tell you whether your answer is correct. So it's a great way to check your work on a test. All right. So they want me to draw my own boxes, which is not so hard. And listen, it's not an art class, so if the boxes aren't perfect, it's not a big deal. 3x minus 7, x plus 5. When you're an architect, make sure your boxes are perfect. All right, so it's 3x squared minus 7x plus 15x and a minus 35. So when I combine the like terms, I get 3x squared plus 8x minus 35. And again, you can check this. Okay, so this is called using an area model or using the box method. And it's a great way to keep your work organized. And you just need to make sure that you have a like column or row for every term. All right, so this is 40x squared plus 12x plus 70x plus 21. And again, the like terms are along the diagonal. So you have 40x squared plus 82x plus 21. All right. Oh, this last one here. This is a perfect square trinomial. Remember, whenever you square a binomial, the answer has a special name. It's called a perfect square trinomial. And that's going to be very useful when you're able to spot those later on. 5 times 5 is 25. 5 times 2 is 10. And 2 times 2 is 4. So we get this perfect square trinomial. Beautiful. Okay, so now we're just doing it using a binomial times a trinomial. So, bi is 2, tri is 3, 2 times 3 is 6, so you're going to need 6 boxes. Okay, so you have 3x times 2x squared, which is 6x cubed. 3x times negative 7x is negative 21x squared. 4 times 3x is 12x. 5 times 2x is 10x squared. And again, you'll see the like terms along the diagonal. 7 times 5 is 35. And 5 times 4 is 20. So again, you get the like terms along the diagonal. And there you go. You get a nice, wonderful polynomial answer. Okay? So if you want, you can try B. And then for homework, it's just practicing what we've learned. Another perfect square trinomial. All right. And this is a great way for you to practice your multiplication. All right. Hope you have a good day. Bye. Stay safe.